Welcome back to Learning from the Core Practicals. The experiment we're going to be looking at today is electrolysis of copper sulfate. Let's have a look at the theory first before we start the experiment. So what actually is electrolysis? Electrolysis is a process used to separate ionic compounds using electricity. So the word electrolysis comes from electro, meaning electricity, and lysis, meaning splitting. Remember, ionic compounds consist of a metal and a non-metal that are chemically bonded. The metal is always positively charged. We call these anions. And the non-metal is always negatively charged, cations. So electrolysis separates the metal from the non-metal. So here's an example here where we've got copper sulfate in solution. Electrolysis will only work if the ionic compound is in solution or if it's molten. This is because the ions need to be free to move to conduct electricity. So it will not work in a solid state. The ionic substance in electrolysis is called an electrolyte. So the solution that you have is called an electrolyte. So for example, in a solution of copper sulfate solution, the ions that are present are Cu2+, so that's copper, which is positively charged, SO4, 2-, so that's sulfate, and that's negatively charged. And then we've got H+ and OH- ions. That's from the water, because water is H2O. So that H+ and OH are separated out into ions when it's in solution. So you can see here those ions that are present are Cu2+, SO4, 2-, negatively charged, H+, so that's hydrogen, which is positively charged, and OH-, negatively charged. These are all going to separate out using electricity. So let's look at the method here. You should be able to see it on the screen. The method includes a power supply so that we can use electricity. And you can see the power supply has a positive side and a negative side. The power supply is connected to electrodes. The positive side that's connected is called an anode, and the electrode that's connected to the negative side is called a cathode. So the positive electrode is called an anode. The negative electrode is called a cathode. And you can see in the diagram, the positively charged ions in the solution have moved to the negatively charged electrode, and the negatively charged ions have moved to the positively charged electrode, and that's because opposites will attract. Okay, so here we've got everything we need for our experiment. We've got our copper sulfate solution in our beaker. We've got our 2 graphite electrodes. You can do this using other metals as well. I'll show you that in a later experiment. And we've got our power supply, and we've got this little nifty piece of styrofoam here just to help us keep our electrodes in place. But what we're going to do first of all is measure the mass of our electrodes. Now you always have to measure the mass before, otherwise you won't know what's happened to the mass afterwards. So if we take a little look at my screen, let's just see what we predict based on what we already know about the chemicals involved. So we've got our copper sulfate solution. You know what ions are present here, okay? Now our copper is positively charged, but we also have hydrogen in here in the solution with our water, which is positively charged. But our copper is less reactive than hydrogen. So because it's less reactive, the copper metal will be produced at our electrode. Okay, and our copper, we've said, is positively charged. So the copper you should see forming around our negative electrode, which was called the cathode. So the copper should be forming around our negative cathode. The OH minus ions are negative in solution, and they're attracted to the positively charged one once we've got this plugged in. So you should see oxygen gas bubbles forming around this in solution. Okay, so let's do this now. Let's put it all into place. Okay, so we'll do step one. We're going to measure the mass of our electrodes. So let's start with our positively charged anode first. It doesn't matter which one you use for this. It just depends on which part of the power supply you connect it to. Okay, so I'm going to take the first electrode, measure the mass, and it's 3.57. That's the mass before, and we need to make sure that this one is connected to the positive part of our power pack. So that is the one that we have used with the red wire. It doesn't matter which one you use, which wire you use for each, as long as you know which one is which. So the red one we've used for positive, the black we're going to use for negative. You can do it the other way around if you wish, as long as you remember which one's which. Let's measure the mass of our cathode, our negatively charged one now. 3.49. Now, what we'd expect to see is the mass of the anode should decrease, okay, because it's going to be losing oxygen. And the mass of the cathode, the negatively charged one, will be gaining the positively charged copper. So it should be gaining mass. That's what we'd expect to see, because the copper is transferred from the solution into our negatively charged cathode. Okay, so I'm going to connect this up now. Make sure it's in the solution. And I'll turn on my power supply. I'm going to put this on to 0.5 volts. And I'm going to be leaving this for 5 minutes, okay? So I'm going to pause the video. You don't want to sit and watch this for 5 minutes, and I'll bring you back and show you what the result looks like. Okay, welcome back. It's been 5 minutes, and you can see very nicely here that we've got the bubbles of oxygen forming at our anode, okay? And that's positively charged, so the negatively charged oxygen is forming here, and we have got our positively charged copper metal forming at our cathode. Now this is a really handy thing to remember actually. The metal in the solution will always be positively charged, so the metal will always form at the cathode. Okay, you will always get the metal formed at the cathode and the non-metal formed at the anode. If you remember that, you'll get the questions right for electrolysis every single time. Okay, so let's have a little look at quantifying our results here. So I need to be very careful. I don't want to knock the copper off of our electrode, because that will mess up our results. So I'll just be as careful as I can, but I do want to make sure as well that I just pat dry. I don't want to lose too much of the copper, but I need to pat dry because I don't want any water affecting our results. So let's measure the mass here. And it's gone from 3.57 3.5. It's gone from 3.49 to 3.54. So the positively charged metal, the copper, has moved onto our cathode, and now it's got a higher mass. Okay? Our anode, let's look at that now. We'd expect to have lost mass. Let's hope that we've got a nice result for you today. I'm just going to pat it dry so no liquid affects our results. Let's see, have we lost mass? And it's gone from 3.57 to 3.42. So we have lost mass. So that's a brilliant set of results there for you to see today. And hopefully when you try this experiment, you get some nice similar results yourself. And just one point to note when you do this yourself, and the mistakes that are normally made, remember to measure the mass beforehand, and remember the electrodes to dry them before weighing them so that they don't appear heavier than they actually are. So you might now have a go at doing this yourself, or you might just be watching this video for revision. But I'll move on to some exam style questions for you now. So welcome back. Let's do some exam style practice based on electrolysis now. This is a really common topic that comes up in exams, so it's important that you really understand what's happening, you understand what's positive and what's negative, etc. So the first question, what is electrolysis? Worth 1 mark. Remember to split that word in half, that will help you. Question 2, in what state must the electrolyte be and why? Remember the word state means, is it solid, liquid, gas or aqueous? Question 3, which electrode do the anions in an electrolyte move towards and why? You need to know here, what is an anion? Remember, is it positive or negative? Question 4, explain why the mass of the anode decreases when copper electrodes are used to electrolyze a solution of copper sulfate. So we didn't use copper electrodes today, so that's a tricky one to think about. It will really stretch you. Have a go to see if you can answer them. Pause the video now yourself and we'll come back to see the answers. Okay, well done for having a go at that. Let's go through the answers and see if you got them right. Electrolysis is a process that uses electricity to separate ionic compounds. Remember, an ionic compound is made from a metal and a non-metal. Electrolysis is separating the metal and non-metal in an ionic compound. Question 2, worth 2 marks, so you need to give those 2 answers. What is the state and a reason why? So it must be in solution or molten, that's worth your 1st mark. So that the ions are free to move, that's your 2nd mark. Question 3, which electrode do the anions in an electrolyte move towards and why? The anions move towards the positive anode because they are negatively charged and opposites attract. And finally, question 4, again this is worth 2 marks. Why would the mass of an anode decrease when copper electrodes are used in a solution of copper sulfate? Copper is transferred from the positive anode to the negative cathode. So that in this experiment, when we use copper instead, the copper moves from the solid into solution and across to the negative cathode. So that's a bit of a trickier one, and it's worth 2 marks. Thank you for listening to my video. Feel free to watch it as many times as you want to help your revision and practice the questions as well. And enjoy any of the other experiments that are up on the school's YouTube channel.